Imagine you're choosing a teammate for an important project. Two students volunteer, but there's only one spot available. You look at their previous exam scores and discover something surprising. Both students have exactly the same average score, 90. So the question is simple: which student would you choose? Here are their scores. Student A scored 89, 90, 91, and 90. Student B scored 70, 100, 90, and 100. Different patterns, different impressions, yet the average is exactly the same. Most people instinctively prefer student A, but others are attracted by student B's perfect scores. But why? If the average is identical, why do these students feel so different? That simple question leads us into three of the most important ideas in statistics and machine learning. Whenever we analyze data, we're usually asking three questions. What outcome should we expect? How much does it fluctuate? And what variables move together? These questions introduce expectation, variance, and covariance. Suppose student A takes another exam next week. What score would you predict? Probably around 90. Now ask the same question for student B. Surprisingly, the answer is also around 90. That's exactly what expectation means. It describes what is typical. If expectation told the whole story, these students would feel identical. But they don't. One feels reliable, the other feels unpredictable. Clearly, something important is missing. Let's look at the scores again. Student A stays very close to 90 every time. Student B jumps from 70 to 100 and back again. Both have the same expectation, but one changes much more than the other. That difference is called variance. Think of variance as a measure of stability. Low variance means reality stays close to what you expect. High variance means reality can surprise you. Expectation tells us the destination. Variance tells us how bumpy the journey will be. But statistics doesn't stop there. Sometimes we're interested in relationships. When one variable changes, does another change with it? Think about temperature and ice cream sales. As temperature rises, ice cream sales usually rise too. Or think about temperature and jacket sales. When temperature rises, jacket sales usually fall. Covariance measures these relationships. Expectation tells us what is typical. Variance tells us how much it fluctuates. Covariance tells us what moves together. Together, they provide a much richer understanding than the average alone. Whether you're studying statistics, building machine learning models, analyzing financial markets, or predicting the weather, these three ideas appear everywhere. They help us understand not only what usually happens, but also uncertainty and relationships. Let's return to our two students. At first glance, they looked identical because they shared the same average score. But after looking deeper, we discovered a completely different story. The next time you see a single average in a report, an article, or a dashboard, pause for a moment and ask yourself, is there more to the story?